Welcome back to the bench, and today we've got a rather neglected Linn Drum LM-1. You can see the main capacitors here are leaky. I've already ordered some very nice Nichicon capacitors to recap this power supply. I'm sure that they all need doing. And looking around, nothing looks blown up or overheated. This side of the circuit board looks pretty good. But then we get over to the RAM chips, and you can see that the substrate seems to have leached out of there. I don't have a machine that can really test these RAM chips, so I'm not sure how easy they are to get hold of, or how easy they are to test these ones. So that'll be something that we'll have to conquer. And inside, all that white stuff has kind of contaminated the whole inside of this unit, so I've no idea if that's dangerous, so I'm going to first of all give this a good cleaning out. Next thing we're going to have to look at these rechargeable batteries, which are absolutely disintegrated. This connection's not even connected, it's corroded off, so we're going to have to pull those out and see if we can find some alternative. Okay, so we can remove these batteries. They are responsible for keeping the RAM alive, so I'm wondering if I have to find some replacement of these in order to start up the Z80 CPU in here. We'll cross that bridge when we get to it. So I'm just going to tape up these battery terminals. Okay, we have some sort of power. Obviously the micro is not running. We've got 9 volts. We've got 5 volts. Oh, we don't have negative 15. And we don't have positive 15. Okay, so if I check continuity between the plus and minus 15, I'm getting shorts to ground. So let's unplug the connector to this board and see if the short goes away. Okay, so I've unplugged the connector, and that's one rail. And is it still shorted? Yeah, the power supply is still shorted. So I'm just going to disconnect the rails on the power supply end. Okay, there's no short across the power supply itself, but we still have a short. So it also goes to the bottom board. and there's this other lead that goes somewhere to the front panel. We've also got these disconnected. Let's see if we've actually got any voltages. Oh, we have a -15 and we have a +15. So the power supply is actually running. Either this front panel connector here, difficult to get to, but also it goes to this bottom panel here. So let's unplug that one. Okay, and the short's gone. So we know the short's on that bottom panel. Here are some really old bypass caps. Let's just get them out of here quick. Okay, so let's measure these capacitors. They should measure 10 microfarad. This one's pretty good. Fairly good ESR. A little bit higher than I would like. So let's check this next one. Oh. Okay, this one's not working at all. So that's a really bad one. And the third one. Oh, that's what's causing the problem. Okay, so I managed to find some nice Nichicon ones. They're 10 microfarad, and I did have this run out, so I've put this radial one I had in. So let's plug it back in and see what voltages we get. Okay, all voltages were present then, so let's just see what happens if we turn it on. Well, we've got a clock signal to the CPU, but the CPU is not running. It's just hanging. There's the same age caps on the top board here, so we might as well just replace them as a matter of course. And I've got some more cleaning to do with this white residue that's all around the place. Oh, we've got some sound. Now by chance on a reboot, the micro is kind of running and triggering samples. It's still not like completely working properly, but even though the RAM chips did clean up, I don't think that they're going to be working. But that's a cowbell. Some of these are just playing sort of sine wavy type thing. And that's a tom. I'm sure they're supposed to be different pitches. And some more whining. But it's showing us that... oh, a cymbal. Showing us that some of it is working. Let's see if we can change the pitch. That's the cowbell. She wants to come back to life. I really hope this is not her last words. Well, even in this unsorry state, it's still fun to play with. crashed. So I've just found this PCB underneath the main circuit board, and basically it was, I think it's an add-on they did. So there's a 10 volt rail that gets created, which is tied to the mains voltage, and when that drops below a certain threshold, it will make sure that the contents of the RAM is safe. As you can see, it's quite extensive mod. I'm sure these are like changes they made. I think they only made 500 of these machines or so. Kind of fairly hand built by the looks of it. But we're going to have to come back to this when we check the reset lines going to the micro. Yep, that cable seems on. And the other thing I have to deal with is things like this. This chip here has a leg bent over. Is that intentional or is that by accident? I've had a look on the schematic. I don't see why it shouldn't be connected. So I was trying to lift out this RAM IC and I thought I'd completely blown it, but actually it was just this plastic socket that came off. You can still needs a clean. But for now I think I'm just going to put it on. I'll still clean it up as much as I can. And I've decided to use my tweezers, bent tweezers here, because I can get under the chip and then force the back end up as well. And these are particularly in tight. Thought I'd do some rudimentary checks, just measuring the resistances between the power rails and ground on these ICs, which is quite worthwhile doing. All these here measured over 2 megohms, even some of these older ones, and I'm going to replace them anyway, I think. But still, these ones here were a megohm or over. So these two at the top, which were all furred up, they still measured about 1 megohm or over. And all these ones measured under 1 megohm. And in particular, this one was about 100 kiloohms. So as a rudimentary test, you can see there is some variance there. But I think I'm going to replace them all anyway. Okay, we'll just give it a quick turn on, make sure nothing blows up. I'm sure the micro isn't going to run. Yeah, it wasn't going to be that easy. So, but we really need to pay attention now to the reset lines and just make sure that the micro is up and running. So I hooked up scope probes to the reset line and the clock pulse. Everything looks alright, at least the reset line comes up. Okay, that's not what I was looking for. 1.72 milliseconds. It's going to need a lot longer than that. So I've taken out the resistor from the board and replaced it with my decade resistor box. So I can have a little play around, see if I can change this time constant for when the reset line turns up. Oh, I've just turned it on, and luckily the micro's in this loop again. So there's some extra sounds playing that weren't playing before. So I'm just going to have a little play around here, see what sounds. Still no snare. The hi-hat we had before. No claps. Tambourine on a short loop. I'm pretty sure that's what we had before. Tom. Got the high tom. It was triggering the low tom before. Still sounds great. I don't think we heard the conga before. Cowbell, yeah, we had the cowbell. No one can forget the cowbell. And we've got the clave. And we have the click. Now this is interesting because the click is software generated. So the fact that it's actually producing a metronome sound, I have no idea what the original sounded like, but still, things are looking up for this little microprocessor. Let's get back to monitoring the reset lines. So there we can see the voltage rails. The yellow is the main 5 volt, the pink one is the battery, and the blue is the reset pulse. So a strange thing was, I think that those just two faulty, there's like a 10 UF cap and a resistor, had just gone out of spec, because I came to the same values after I replaced them with a new cap and my Deco resistor box. And if I can get my cursors, now we're getting 5.64 milliseconds before the reset line comes up. And as you can see, that's about half, just over 3 volts from where the 5 volts is. So that's looking better already. Oh, I've just realised that purple line is actually the battery, backup battery voltage, which of course we don't have any backup batteries here connected. So let's sort that out. Actually, I went on a little side quest here. I decided to write a little program for the Arduino so we can test this RAM IC and some of the others. There's the new battery I've got, so we can get back to testing the reset lines and stuff. But at least this will give me an even better idea of what sort of state these RAM chips in, even though I'm going to replace all the RAM chips. So I've just got some code to toggle some pins around. I've got a current meter on the USB here, so I can see if any of the RAM chips are pulling any excess current. Okay, this is not a fully comprehensive test, it's just really to get some idea of what state these RAM chips are in. So if I power it up, and then we can see data on all the address pins, and most importantly on the data out pin as well. And whilst I'm there, I can just check how much current it's drawing. So I managed to find a decent replacement for the NiCad rechargeable battery. This is from RS, and just remind you what the other batteries look like. Complete mess, but they are pretty identical. These are 2 milliamp hour. Is that right? No, 2 amp hour. These are 4 amp hour. So I can monitor the voltages even while the unit's off. So to be on the safe side, I'm going to actually run the battery from my bench power supply, so at least I can set the voltage and the current limit. And I'm interested to see what happens when I insert these ICs and see what the current draw is. And I'm monitoring on the multimeter the voltage that's getting to the chips. So I'll just whiz through all these. Okay, that's interesting. The voltage has dropped. And if I swap this chip with another one, if this comes back to 3.5, then definitely these ICs are going to be changed. Yeah, so that last one was pulling too much current. So now I know everything's safe, I can actually connect the battery. And the power is off at the minute, and we are getting 3.3 volts arriving from the battery. So I guess when we switch it on, it will charge up and we can monitor it from there. And we'll wait for these RAM chips to turn up. And if you've seen my last video where I was having trouble reading some binary counter chips, found 3 faulty binary counters on the bottom voice board and made this breadboard to do some testing. Turns out my old IC tester I think is faulty. If I put in a good 74393, you can see that it shows that it's a good 393, and the new ones that I bought from RS, when I put them in here, it says not found. But with this new tester that I've got, this can test the new ones pretty well. So I'm going to go through the rest of the board and just check that all the correct ICs are in the right place. After the Matrix 12, that someone had put the wrong chip in the wrong place, it would be a good idea to check everything. And to help me do that, because this schematic is so bad, I've actually made the biggest Linn Drum schematic known to man, and just to give you some reference, there's a Z80. So while I'm waiting for these RAM chips, I think I'm just going to buzz out and make sure all the correct logic ICs are in the right place. So until then, catch you next time.